greatest integer function. Very simple, but yet very complicated. So just like we will have greatest integer function, and we will have a smallest integer function. So let's see what is it. So greatest integer function, a function f from set of real to set of real numbers, defined as f of x equal to, we denote like this, greatest integer function. We denote the greatest integer function like this way: for all x, element of a set of real number is called greatest integer function. We'll say a function f from real to real defined as f of x equals to x element of real set of real number has values of the greatest integer less than or equal to x. So what does this mean? To understand this, I will first plot the graph. So if you plot the graph of greatest integer function, you will see something like this. So you will see, so this is 1, minus 1, minus 2, minus 3, and so on. This is 1, 2, 3, 4, so on, and this is also 1, 2, 3. This is minus 1, minus 2, minus 3, and so on. So you will see there, you will find that for minus 3, this is minus 3, there is a dot and there is a hole here. Now what is this? We will see this, don't worry. And again a hole, a dot and a hole. Here is a dot and there is a hole, okay, and then here we have a dot and there is a hole, they are joined. Again there is a dot and hole, dot, hole, dot, hole, okay. So what is this? Let's say I give you this 0.5. So what is the greatest integer? What is the greatest integer less than or equal to x? So here 0.5 is not an integer. However, less than or equal to, so this is our x. So what will be the greatest integer? So greatest integer will be 0. So the answer will be 0. Less than, not more than. We cannot take 1. 1 will be greater than. So where does the in the graph, where does the 0.5 lies? 0.5 lies somewhere here, right? 0.5 lies somewhere here, right? So we'll have to take 0 and we will not take 1. So y value will be then 0. Similarly, if I give you another value, let's say I give you minus, if I give you minus 4. So what is the greatest integer less than or equals to x? So here minus 4 itself is an integer and it is less than. So less than or equal to. So here it would be minus 4 only. Now if I give you 1.35, let's say I give you 1.35. So what will be the greatest integer less than or equal to? So 1.35 definitely is not a integer. So it would be it is a real number, set of real numbers. So what do you think it will be? Its value, y value would be what? So the less than, it would be 1 only. The 1 is the nearest. So if I look at in the graph, 1.35, 1.35 will be, let's say, somewhere here. So the lowest integer would be here, what? 1. So it should be 1. So if you understand the graph, it will be very easy. It will help you to understand. If I can give you, let's say, minus 2.75, minus 2.75. So what do you think will be the greatest integer less than or equal to x? So in this case, where is 2.75? This is minus 2. So 2.75. So this is 2.75 will be somewhere here. 2.75 will be somewhere here. So that means, so greatest integer in this case will be what? Less than. We are not talking about greater than. So if I could have, we will not take -2. So less than will be definitely -3. So -3 will be the answer. Okay. So what is the domain and range then? Let us see the domain and range of this function. So domain will be R only, set of real numbers. However, range will be set of integers, because it will be all integer only. So it will be all set of integer. Now similarly, just like we have a greatest integer function, we also have a smallest integer function. So what is the smallest integer function? A function from real to real, defined as, so last time we used to denote greatest integer function like this, x this way, half be a square bracket. So now in this case it would be, you see there will be the square bracket would be at the top. So this is the greatest integer function defined as f of x equal to has values of smallest integer greater than or equal to x. So if we plot the graph now, just plot the graph. So again, so this is -1, -2, -3, 1, 2, 3. This is -1, -2 and -3, so on, -3. This is 1, 2, 3. So the graph is now, so here is -3. The whole will be on the left side now. Earlier it was on the right side, now it is on the left side. Okay. So let us see, take an example. So if I give you an example, let's say -2.7. So 2.7 lies where? So where is 2.7? So this is 2, this is 2. So 2.7 is somewhere here. So we have to take the, so here is somewhere is 2.7, we have to take the 3. So the answer will be 3. Okay, sorry, I have said -3, no, sorry, so let's make it plus. Let us do another one with a -1. So if I take this as -2.7, let us see -2.7. So -2.7 is, -2.7 will be -2.7 somewhere here. So we'll have to take -2. That's it. Now, so another example. So you can now, you have got the picture that this is how. So if I take one more, 1.7, let's say, so 1.8. So what is the greatest integer? Look at the graph, 1.8. 1.8. So 1.8 would be here. So 2 is the answer, and so on. Okay. So what is the domain and range for this one? Domain and range, again same thing. Domain will be set of all real numbers and range will be set of all integers. Okay. So these are the two very special functions. They are a little complicated, but they're extremely easy also, but little complicated also at the same time. So remember this diagram. If you can plot the graph, is very easy to understand. And I'm giving a hint. Greatest integer less. So if it is great more, opposite will be, along with it would be, opposite of greatest is less. So it will be greatest integer less than. And for the just one smallest, so it will be greatest. So So remember like that. And if you can plot the graph, so for the smallest, all the holes will be in the left side and all the dots will be on the right side, and for the greatest integer function, all the holes will be on, all the dots will be on the left side and all the holes will be on the right side. Okay, thank you.